Thank you, and welcome to my talk about motion control with multimodal AI. I gave a longer version of this talk recently at another conference, and a colleague of mine watched the recording, and she was like, oh, it's like a magic show. So hopefully, if everything works well, it will feel maybe like a magic show, but then you'll also understand how it actually is all built. So I was briefly introduced. I'm going to go quickly over this. So yes, I'm a senior research engineer at CrowdStrike. I go by Charlie online usually. I'm an author, front-end master's instructor, so I've been doing kind of things with machine learning on the web for about like 8 years now, but primarily using TensorFlow.js before, and this is going to move on to the more recent advancements with multimodal AI. Overall, I guess I'm a self-proclaimed creative technologist, so I like to push the boundaries of what can be done with JavaScript and the web platform, and sometimes try to use tools to kind of make it do maybe what it wasn't necessarily built to do. And outside of tech, I've been spending a big part of the year trying to have hobbies that are non-tech related. It includes diving, running, hiking, playing drums, learning German, and I also got my radio license earlier this year. It's a very niche hobby, so I don't know if anybody here knows what it is, but in case you do, my call sign is KO6HPR if one day you hear me on the radio. But let's start by talking about previous experiments. So when I introduced myself, I just talked about TensorFlow.js, and I want to cover a little bit the things that can be done with that tool, so then you'll understand a little bit why I'm also experimenting with this with multimodal AI. So there's a few different models that you can use with TensorFlow.js, and one of them is about pose detection. It's called PoseNet or MoveNet. There's a second one as well. And usually you get key points. So forget about the green lines. It's like the red dots. Depending on the model, you get a different amount of key points. And these key points are raw data. So it's coordinates, x and y coordinates relative to the screen. And with this data that you get, you can build something like this. So this is a clone of Red Light, Green Light, the game from Squid Game. So if you have not watched this series, basically you have a doll, and when it looks at you, you're supposed to like not move, and when the head is turned, you're supposed to like, or in this case, run as close to the screen as you can. Otherwise, like you die. Basically, if you move when the doll is looking at you, you die. And I wanted to recreate something using PoseNet, and then you start thinking, well, how do I actually code like the fact that I'm not moving or moving? So we're not going to answer that question in this talk, but if you want to think about it later, it's pretty interesting. So you can decide, do I use all of the key points in the body? Do I only focus on some of them? What does it mean, like in terms of logic and things like that? But if you want, you can also focus on only some of the key points. You don't have to use all of them. So in this other example, it was a clone of Beat Saber, where originally the UI was an open source repo that was on GitHub, and it was supposed to be connected to a headset via like using WebVR. And you were supposed to be able to connect this app to joysticks using JavaScript, but I didn't have a VR headset, and I was like, I have hands, so I can just like play Beat Saber with my hands. So I was basically used two of the key points from PoseNet, so my right wrist and my left wrist, and then I kind of used these directions or these coordinates, translated them to the VR world, and being able to kind of like play Beat Saber with my hands. Another model that you can use is one that is specifically around key points on the hands. So right hand and left hand, and here I think you have about 21 key points, and you can build something like this. So I started thinking, well, what if you could augment the tools that you already use, but add some kind of motion detection to it as well? So that was interacting with Figma. So it's not necessarily that all of a sudden you will build entire interfaces just with your fingers, but what if you just were augmenting the type of things that you can do? In this example, I think I was using just like a pinch gesture to be able to drag shapes around. And then here in this GIF, it's like basically when I move my hands like this, but when I do like a palm gesture, then this is a zoom. And you would also have to write that own logic. It's like, what's even a palm gesture versus like a fist or something? And then you measure the distance between your hands, and you can do whatever you want with it, really. And finally, another model that you can use is around more face detection key points. This one has more than, I think, 450 key points all around the head. And what I focused on specifically is to build a tool to focus on gaze detection. And with this, you end up having even more questions, not only technically how do you build this, but even in terms of human-computer interaction and user experience. If you only have two inputs, left or right, how do you write something? And here it's kind of like reimagining the keyboard as well. So, if you have a keyboard and you want to select the very last letter, you could technically, like, as you're looking right, like select, go letter by letter, but that would take a while. So then you could rethink the keyboard and see, okay, if I split the keyboard into two lists of letters, And let's say I want to write the letter W, and it happens to be in the right column. Then look right quickly, and then it splits that column again into, and you end up with kind of like a binary search, and you end up being able to select a letter that's like far on the keyboard but faster. And then you would select it with like blinking, for example. But with this same concept, then you can start thinking, well, what would it mean to code using only two inputs, left or right? And it's a nice exercise to be thinking about our interfaces in the way that we actually interact with our tools in general. And again, it's not necessarily that you would have to replace entirely writing with your eye movements, but even in terms of thinking about what it means to code, now we can ask whatever, ChatGPT, and it will spill out a code sample. But before you'd be, OK, when you code, there's only a certain amount of things that you can do, or there's only a certain amount of ways to define a function. So you would kind of have a list of the available things that you can do, and then you could also have like a tool where, again, like the keyboard before, you would look at sides of the screen to select what you want to do. And then you can use like snippets on VS Code, especially for React, where if you want to create a function, then you would look to the side where the function option is. And then when you blink, it would almost like simulate that you're doing a tab, and then it would write the component. So this works really well. Like, it's kind of fun to be working with these coordinates. But at the same time, it means that everything that I'm doing is that I, as an engineer, have to define what these gestures are. So for example, if you're using the hand and you do a thumbs up, it's like, well, how do you code what a thumbs up is? If, for example, you were doing like, oh, well, if I don't see the tips of my fingers because they're folded, and let's say if the angle between my thumb and the rest of my hand is like, I don't know, 90 degrees, then it's a thumbs up. But then what happens if a user is like tilting their thumb a little bit more? All of a sudden, it's not 90 degrees, even though you know I'm still doing a thumbs up. So it becomes a little bit more difficult to have something that can be shared by a lot of people. So then I started wondering, OK, can LLMs be used for motion control? So I know that when you think about LLMs, you think about language, so text. But let's say more recently, we're talking about multimodal AI. Actually, that's not what I'm going to show. So yeah, it's like LLMs or multimodal LLMs, multimodal AI. It's like feeding or augmenting what you're giving the LLM, and we're starting with pictures. But the inspiration for what I'm going to show in this talk is something like this. It's called the Room E project by Jared Ficklin. It goes all the way back to 2013. So I've been wanting to do this for 12 years. And in this example here, there was actually a Kinect sensor. It's like basically like a depth sensor. And in his example, he was looking at how tech could be added to like almost like room-sized computing, and you would be able to communicate with devices with voice and gestures. So in this example, there's two lights, and he was pointing at the light, and he was like, turn this light on, and then turn that light on. And it would kind of understand based on gestures and what you're saying, which light to turn on, and it would understand the commands turn on or turn off. But in this example, again, it's using a Kinect, and I think they don't even sell the Kinect anymore. So I wanted to see if we could do things with what's in the browser and all in JavaScript and something kind of like similar. So hopefully, if the demos go well, we should see that it is kind of getting closer to something that's possible. But again, it means that hopefully as well, there's not that much code involved. And now that people are getting used to interacting with AI anyway, we could get to a point where things like this would require maybe just a camera, and the rest would, like AI would kind of understand what you're trying to do, or it would learn about your gestures and the way you want to interact with interfaces, rather than, as an engineer, you would create an app and you say, oh, the only gesture you can use to turn the light on is like pointing, and like, what if I don't want to point? And like, you could retrain your AI to understand what you want to do. So yeah, I mentioned multimodal AI. There was a few talks about AI today, so you probably know by now, but quickly, it's a machine learning system that can process multiple types of data, such as text, images, and sound. So here, because we're talking about gestures and we're going to use the webcam, it's mostly images that are then, they're going to be a label that's going to be then fed into an LLM, and this is where the LLM comes in and the text input. So the purpose of this is to research how or if LLMs can be leveraged to create motion control experiences. And usually when I do personal research, I also set myself a specific goal, because you can go on forever in research, and then at some point I kind of want to move on to something else. So my goal is to control a website or an IoT device with hand movements using Gemini. The only reason why I'm focusing on Gemini specifically is because it's free, and I'm doing this not as part of my job. I'm not paid to do this. So it would be interesting to kind of switch and see if using other models would be more or less accurate, or maybe there's different things that you can do. But in this talk, it's going to be Gemini specifically. So there's a few different approaches that you can take, or at least that I decided to take when going through this. So first of all, I was thinking, if we rely only on multimodal AI, first let's try with that. So Gemini takes screenshots, and it returns its best guess for the hand gesture that I'm executing, and then we can try to trigger stuff. The other approach is well, if I know TensorFlow.js, can I start to rely on multimodal AI, and then augment it with more fine-grained data and gestures from TensorFlow.js? Okay, that would be second approach. And then the third one would be to do all DIY, or at least the gesture recognition, where I would take screenshots from the webcam, I would convert it into vector embeddings in JavaScript, save it in a custom vector DB, and then use Gemini only for the function calling. So if you're thinking maybe about privacy, when I'm giving images of myself to Gemini, I don't know where it goes. I don't know, if it's used to train something else, and maybe you don't want that. So if you are creating your own custom system, you could still use Gemini. Then when the label of your gesture is returned from your vector DB, you could then just rely on the LLM like Gemini. You wouldn't have to augment it with images and stuff. So full disclosure, this third approach, I'm still working on it, so I'm not going to be able to demo it today. But I think it's actually something that can work. It's just that this is ongoing research. So I still wanted to mention it, that this is one of the approaches that I'm trying. OK, so gesture detection with Gemini. I used their starter repo. They have something called Live API, Web Console. It's a starter repo in React that kind of sets the skeleton of how to use multimodal AI using Gemini. Again, my purpose or the point of my research is to focus on the motion control part, so I didn't want to build something from scratch. So if you're interested, if any of the code sample that I'm going to show later, I'm going too fast over it or it's not enough, there's actually a starter repo that you can start from. So showing a few code samples. So at first, you have to start by configuring the model. So I've been using Gemini 2.0 Flash experimental. It's kind of an old one now, as of, I think, 2 weeks ago. I think that now there's a new one that you can use, and I haven't tried it. I'd be curious to know if it makes the predictions better or faster or anything. But for my experiments that I'm going to show you, this is the one that I'm using. Then you can set certain configs, so you can tell the model if you want to have responses in text format or if you want it to talk to you. Here I have audio, so that hopefully if everything is set up properly, you'll also hear the AI talk to me. But the most important part of it is your system prompt. So for my first experiment, I wrote something quite simple. I said, you're my helpful assistant, looking only at the hand in the stream from the webcam. Make your best guess about what the gesture means. Don't ask for additional information, just make your best judgment. So we're going to start with that one. OK, so here, hopefully, that should be zoomed in. So what's going to happen? I'm going to tell you what's going to happen, so that then if it doesn't work, you'll know. I won't be able to hide. But on the left column here, there's going to be basically the output of the model. And you should see, so in the center, I'm going to have the webcam. I'm going to make a gesture in front of the camera. And you should see the label of that gesture answered by Gemini. You will also, just to precise, I'm going to say a trigger word to start the functionality. In the end, what I would love is for it to work without having to talk to it, or you can programmatically send a start input, but I found that it was quite messy when I was doing this. So I'm just going to say the word now, but it could be anything. I could say beep boop or whatever. It's just a start command. OK, so camera is on. I should be all connected. OK, so now, what? OK, now, OK, cool. So if I don't know if it was too small or something, but it said thumbs up and then said peace sign. I'm not going to show too many of them, but then you can experiment, being oh, what can Gemini by default? Oh, no, not that. Don't see the mess on my screen. So I'm going to just do that. And yeah, so what was cool here is that the only prompt that I said was just look at what you see and just give me a label. And there's a few gestures. I think it can also do thumbs down, or when I do a stop, then it's usually it comes back with the label stop. So I haven't tried with so many gestures, but I'm OK, we can start by, if we only want to rely on Gemini, we can get some kind of labels. That's cool, but we want to move on. We want to do something, right, with this gesture or with this recognition. So now we're moving on to function calling because we want something to happen. And here we have to start by declaring some function declarations, which are schemas of like the way you're going to define or how your function is going to be kind of set up. So I have a function here. The name is going to be toggle light. I'm setting a few parameters, and I'm saying that this function should have a parameter that's a type of object, and the properties, it will have a property on. That will be a Boolean, and it's a light, and I'm just describing that this Boolean is going to be the light state as a Boolean, and I make it required. So Gemini should not call this function without the on property that should be a Boolean. And then here, that's like more classic front end, but just so you know that there's not really any magic there. I'm just sending, if the command on is true, then I'm sending to the API the string on or off. I'm using the LifeX light bulbs. So at home, I also have the Philips Hue light bulbs, but you have to connect them with a bridge to your router, and obviously I can't do that if I'm speaking at a conference. So these ones are really cool. As long as you're on the same network, everything, so I'm hotspotting off my phone, it works. And it has like little Wi-Fi chips and stuff in the light bulbs themselves. So yeah, here you just ping the API like you would do on your day-to-day job, probably. And OK, and one important thing as well is that I have to update my prompt to the model, right? Because at the moment, my first prompt, I just had tell me the gesture, but now I have to say, call the toggle light function provided. So once you have the gesture, call the toggle light. But I'm kind of not saying anything else. So, and I'm just passing the function declarations after. So I also wanted to experiment, what can I do with like a very small prompt? I don't have to like write a super big stuff. So let's see if that works. It should. This one should. I know there's a demo that's probably going to fail, but we'll see. OK, so what I'm going to do, OK. Should I tell you before or after? I'll tell you after. Okay. So, OK. Now, did he do it? Oh, OK. Now, that's cool. I'm actually surprised because when I rehearsed earlier, there was a bit of a problem. So what's interesting in that one is that I did not tell Gemini which gesture I was going to make, and I did not tell it the thumbs up means on, thumbs down means off. I just said, make a guess about your gesture, and then call the toggle light on with the on. Well, I mean, I didn't even say with the on property because that's defined in the schema. So what was interesting here is that, well, a thumbs up is usually like a positive gesture. So then, again, I hate talking about AI in like human words, but like it understood that I meant that, it's a positive gesture, so the Boolean should be on. It's a negative gesture, so Boolean should be off. Cool, OK. So far, so good. But what if I have multiple lights? At home, you probably don't have only one light. You might have multiple ones. So then, OK, what do I need to do then if I want to move on to being able to control multiple things? So this is where I move on to multi-turn function calling. I saw it recently called also compositional function calling. There has to be a difference somewhere. I do not know. But if you come across these terms, that it just means calling multiple functions. So the first step that we have to take is in our toggle light function in the schema, we have to add a light ID, right? Because obviously, to know which one that you're going to be able to toggle on, it's going to be either one or the other. So you need to pass in a light ID. That's going to be a number. The description is the ID of the light to toggle, returned by the getLight function. And here we have to add another object to our schema. So we're going to add a function that's called getLight. And I'm going to add like a property that's going to call like details, basically. And here I'm saying that it's a string, and the description that I gave it is like the detail about the light, usually a position. And the reason why I specifically in my experiment wanted to use a position is because I don't know the IDs of my light by heart. Even if I was talking to the AI instead of making gestures, I'm not going to say turn light ABC 1, 2, 3, right? So I want to be able to say turn the right light on or turn the left light on. And if you have any of those lights at home, you know that usually when you're setting them up on the app, you can set a custom name. So obviously, so the light on the right is called right light, and the light on the left is called left light. So what I want to try to do is point in different directions. It should understand the way that I'm pointing, either left or right, and then that will be passed to the getLight function, and it will filter through the names of my connected lights and then return the ID and pass it to the other function. So I have to update the prompt again, because now I have multiple lights. So I'm saying look at which hand is making a gesture, right or left. I probably didn't need to add that, but just in case. And then call the getLight function provided with the correct hand position. Then make your best guess about if the gesture means light on or off, and call toggle light. I think what's interesting experimenting with this is that sometimes you change the prompt just a little bit and they have totally different output, for better or worse. Yeah, sometimes it's not that great. But this is the prompt that I'm using for that one. In terms of tool call logic, I'm going to go through this quite quickly because you can look at the code on the repo. But when you use the live API for Gemini, you have different hooks that you can use. And on tool call, so when the AI figures out that you're trying to call different functions, we have two functions here, get light and toggle light. Here, it's going to list the functions that I'm supposed to be, or that the AI is supposed to be calling based on the prompt that I gave it. I have an array for the function response parts, because the response from getLight is going to be the ID. I'm going to have to pass it, or it's going to have to pass it automatically to the toggle light function and things like that. So here, I just loop through the function calls. I extract the name, the arguments, the ID. I just call the function that it thinks should be the first based on the prompt again, and I'm pushing the response in the array, and then it's kind of send the tool response. It's necessarily, you don't have to necessarily really understand exactly what is happening here. It's just you have to understand that the AI will figure out on its own which function to call at what time and how to pass the response to the other one based on the schema that I provided. Okay, so this is where there's going to be probably an issue with that one, and I'll explain why after. But the way that this demo should work is I'm going to point to the right. If I'm lucky, probably not, it should turn the right light on. And if I point left, it should turn the left light on. It will probably not work because, weirdly, whatever vision model or whatever they use in the background is not very good at knowing right from left, which I thought was a problem that was kind of solved in computer vision. But let's say that if their model is more kind of tuned to detecting objects and not necessarily body parts, that might be why. But let's see what happens. So if this one fails, I kind of already know, so it's fine. Okay. Now,
okay, I have toggled the lights off.
Well, I mean, I didn't want them off, but okay. Now?
I have toggled the lights on.
But it was saying on. Oh, well, okay. So
how are the lights now?
No. Okay. So the thing is, I think I don't even remember which finger I was pointing with. But it turned on a light. So I don't know if it figured out right or left, but it did a thing. But again, this is where it's actually interesting that if you're trying to, so if I just talk to the AI, let me try something. Turn the left light on. No. Okay. I'm just going to move on with that one. Okay. So let me try that. Okay. So this is not the most interesting one. So, okay. So again, maybe later on, or if at some point we can, I think at some point I was thinking, oh, this is where maybe I could augment it with TensorFlow.js, where TensorFlow would know the right from left, and then I could augment that. But this is where I'm going to move on to something else. So let's add TensorFlow.js to Gemini. So here, I'm building up each demo on top of each other. So we still have our getLight function, we still have our toggle light, but I want to set the color. So I want to use fine-grained data to be able to rotate my hands and change the color of the light. So I'm just adding to my prompt. Then if the user is making a palm gesture, I'm not describing what a palm gesture is. I said, if you see a palm, call the set color function provided. I'm not going to go through what the set color function is, because it's TensorFlow.js. It just detects the hands, and I do what I'm doing is I'm calculating the angle between the tip of my thumb and the tip of my pinky. And if you imagine a horizontal line, as I'm moving in degrees, basically, I'm changing the hue of the light bulb. I mean, that's what is supposed to happen. Okay, so let's see if that works. So this is actually a really exciting one. That's why I want it to work. So just to explain before I do it, the thing is I might have to, okay, I kind of want to see if things are happening. So I might have to do that. Yeah, okay. So what I want to do is I want to kind of build on the demo before. So I want to point to a light. If I'm lucky, it will turn the correct light on. If it doesn't, I think I can still move on. Then I'm going to do the palm. And as I'm rotating my hand, it should change the color. I'm just going to open the console, because if it doesn't work, I'll know. And because it's JavaScript, I'll just refresh. OK. Now,
Okay, I've toggled the light on your right.
Now,
I have set the color of the light on your right to red.
oh yeah, okay, I'm so happy. All right, cool. So it worked. Yeah, no, I shouldn't be that surprised, but because it's generative, you also don't know if it's going to work or not, for better, or worse. But yeah, so that was cool. So it means that you can rely on what Gemini gives you out of the box, and then you can also customize with making kind of more interesting interfaces. So it was struggling a little bit. I don't know if you saw it was kind of slow. It's not usually that slow. So I don't know if it's just like I need to update the model, or maybe my connection is not good. I'm not sure. So also, I'm over time, so I'm going to rush a little bit. So I'm not going to demo that one, but I want to talk about how I would necessarily do it. So I explained it a little bit at first, but I've been using a platform called DataStax. And you could have, again, because you can see the stream from the webcam in the browser, you can then take screenshots, transform that into vector embeddings. That will be stored then in a DataStax vector database with a description of my gesture. So I'm kind of like creating my own custom database of gestures. But it doesn't mean that it would only work on me. It means that then if someone else is using my app and somehow transforming into vectors, there's a similarity between a gesture that I already have saved, then it could return the description of that gesture and then feed that to Gemini. So based on the description that you get, do something. And the reason why I wanted to experiment with this is, again, with Google, I don't know where my stuff goes. I don't know if they keep it. I don't know if they don't keep it. And you also kind of I know that it's very difficult to recreate an image out of vector embeddings. So for privacy, I feel a little better if I end up installing that in my house and it just looks at me all the time. I would rather know that I'm sending stuff to my custom DB rather than to Google. And also with the Gemini, if I'm doing a gesture that Gemini by default does not recognize, let's say it doesn't recognize, I think it didn't recognize the Star Trek whatever sign. And it means that if I can train it, I can tell Gemini, hey, when I do this, turn the lights off. But if I refresh, then I'm losing it because it doesn't necessarily save your sample, at least not the free version. So if you do it if you do this, but you save it into your custom database, then it will always be there. Anyway, so I'm getting to the end of this talk. So I added a few resources, but if you have any question and you want any kind of link, you can reach out to me on Blue Sky, probably more than Twitter. And I'm planning at some point to write a blog post about this, but because it's ongoing, and it will be there, but if you're interested, my website is charliegerard.dev. There is already existing research of people who are actually researchers who have published papers about this. And otherwise, I just wanted to kind of end again on the original inspiration. What I love about experimenting with this is that I feel like it's getting closer to something that could actually be happening only with a laptop. And it means that I really want people at some point to be able to, turn these lights on, and then at home they just talk to kind of, whatever AI device that they have, and they get to customize the way that they want to experiment with stuff. And in the end, we could have interfaces where you just boom, 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 and just it just learns what you do, and maybe you don't even have to talk to it. It just learns how you work, and you don't have to buy a Kinect. You don't have to have this really big setup. But it means that already 13 years ago, people were thinking about this. I'm still thinking about this, and hopefully maybe at some point it can actually be embedded in the browser, because now Gemini API is in the browser as well. And we could be hoping, here I showed it with lights, but it does work as well with interfaces. I was thinking, oh, when I do this, refresh. When I do this, change tabs. And if it ends up being then in the browser natively, then people can build their own interfaces. Anyway, I don't know how much over time I am, but I'm definitely over time. So thank you very much for listening, and hopefully you want to experiment with stuff like that as well.